How does life increase entropy despite its order? Imagine a bustling city where everything seems perfectly organized, from the roads to the buildings. Now think about how this city keeps running smoothly. How does it do that while the universe itself tends toward disorder? That's what we're here to find out. Life looks very ordered and structured, with cells, tissues, and complex systems working together seamlessly. But according to the second law of thermodynamics, the total entropy or disorder of the universe must always go up. So how does living things stay so organized without breaking this rule? The answer lies in the idea of open systems. Living organisms are not isolated. They constantly exchange energy and matter with their surroundings. They take in energy from sources like sunlight or food, which have low entropy. Then they use that energy to build and maintain their internal order. While inside the organism, order increases as cells divide and structures form. But this doesn't violate the second law because the organism is exporting entropy to its environment. When cells metabolize nutrients, they produce heat and waste products like carbon dioxide and other gases. These waste products carry away the extra entropy generated during the process. So, even though the organism becomes more ordered, the universe as a whole becomes more disordered. Think of metabolism as a series of chemical reactions that transform energy. Some reactions releases heat, which disperses into the surroundings, increasing the overall entropy. Waste gases and heat are expelled, preventing entropy from building up inside the organism. This process is an example of an irreversible process, where energy is dissipated and entropy increases. On a larger scale, ecosystems show how energy flows and degrades. Plants absorb sunlight, which is low entropy energy, and turn it into chemical energy. When animals eat plants, they transfer that energy, but some of it is lost as heat. Decomposers break down dead matter, releasing even more heat and gases. Each step increases the total entropy of the environment. Life can be seen as a dissipative structure. These are systems that maintain their order by continuously dissipating energy. They form spontaneously because they are efficient at absorbing energy and releasing it as heat or waste. This process increases entropy outside the system, allowing life to exist without defying the second law. In summary, life increases entropy overall by taking in low entropy energy and releasing high entropy waste. The local order we see in living beings is a temporary, controlled decrease in entropy. This is balanced by a larger increase in entropy elsewhere in the universe. So, living organisms are not defying the rules of thermodynamics. They are working within them, constantly exporting disorder to maintain their own order. This balance between local order and global disorder is what makes life possible within the framework of irreversible processes and the tendency toward equilibrium.